and then here to there. Okay, that's fine. However, you can go one more. There's still another one in there you could do. You have one more, maybe. See if you can convince yourself. There we go. U is V, V is T. Tangent S. Good. Good. That's what I'm looking for. Any progress? Did I check y'all on the last question, or did I skip over you? Did I come by? I did? Okay. Okay. Oh, I'll give you more time. Okay. 3 over G. G is fifth root of H. H is J squared. J is tan K. K is M plus 1. Yeah, that'll work. That'll work. Yeah, you went even further. Now the last one is this right here to here is good, but it'll be overkill later for that, because you would be at a polynomial right here, even if you like said m squared plus 1, and once you're at a polynomial, it'll be easy. Like later, we'll be happy. Okay, so he's got it. Yeah, there. Yeah, so you got it down to what, 5 of them? Okay, now try and do it with the letters, like U, V, W type thing. R is cube root. Fifth root. Fifth root. You got to be a little careful here. Hold on. Yeah, you're good. You're good. Well, no, there's a problem here, because you're done with the fifth root, right? So what's the next thing happening after? Like if you go inside the fifth root, what would be? That is. Well, if I write down this, if I write tan squared of, what is it, x squared plus 1, this means tangent of x squared plus 1 squared. Yeah, well, anytime you have this, that's what it means. So if you were looking at working from the inside out, it would be this, then tangent, then square. So coming back in, it would be square, then tangent, then this. Yes, that's right. Did you? Okay. Yes, that's right. Good. Yes, that's it. Anyone here? 3 over S. Oh, well, yeah, you could do it that way too. S is this. That's that. That's that. That's that. That's that. So you have 1, 2, 5. There seems like, hold on, just seems like there's something missing. You have 1, 2, 3, 4, 5, 6. Yes, okay. That'll work. It's not the only way, but that'll work. Okay. Got to be careful on this. Take a look at this again. There's a little bit of an issue here. Anything here? Did I already look at yours? You were good? Fifth root. This is where we have an issue, because if you look at this, the fifth root happens, right? The next thing inside that happens is a squared. So you would need this to be a squared, and then tangent on your next function in. I'm going to work through it right now in just a second. So this is right. That's right. Okay, I'm going to work this one out on the board real quick, just to see there's different variations of this. The way that I would look at this is that, again, I'm going to start from the inside, work out, and then back in, okay? If I'm x, the first thing that happens to me is I get squared, then plus 1, right? X squared plus 1. Then what would happen after that? Does the tangent happen or the squared? Tangent. Okay, so tangent would happen next, then squared, then fifth root, then 3 over that, right? So I think I'll start off with u is equal to 3 over something, v, all right? Now, what's v? It's the fifth root of something, w. Okay, what was w? It's something squared, right? T, whatever you want. I'm going to use q just to show you. You can use whatever letters you want. Q squared. What's q? Tangent of z. What's z? X squared plus 1. Now, you could even go further than this. There are little subtle things you could do at the end, but this is breaking it down. Where look at every function we have here. 3 over v, to compare it to something, is like 3 over x. That's a rational function. It's a power function. This one right here, this is a root function, isn't it? So this is a power. This is a root. This next one is a power function, right? This next one, tangent x, is a trig function, right? And then this last one is a polynomial, right? And what we're going to be doing later is we're going to take some nasty thing like this up here, and we're going to be trying to figure out what its derivative is. And you don't really know what that means yet. But to do that, instead of trying to attack this big, ugly, nasty thing, you're going to break it down, and you're going to do the derivative of a power, of a root, a power, a trig, and a poly. And those will be easy to do. And then you somehow combine the answers together. But you got to be able to break it down. All right. We still have half an hour. To me now, this is actually where the class begins. So are y'all okay? I mean, can I keep going? Have I lost you? Is your attention all gone? You still there? Everyone has the notes for these? Let's see how far we can get with this. I'm going to try and stop myself in 20 minutes because I want to just kind of recap what you need to do, and when you go home, like what's homework, you know, like. All right. So in the past, I've been known to actually start a class first day in 1.3, but I've done a little review for us. All the things we've done are just kind of, they'll pop up here and there. This is where calculus begins, though, for me. It's everything in calculus, in Cal 1, Cal 2, Cal 3, everything is born from the idea of the limit. All right? So what we're going to do to begin is look at, and I don't think you have any of this on the notes. Whoa, 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 whoa. It says, discuss the behavior of this function around the value x equals 2. I think I'm going to kill the light so we can see that a little better. So let's take our time through this because, like I said, this is the most important thing in calculus, is understanding the idea of a limit. So here's our function right here. It's what type of function? Power would be just an x by itself, polynomial. So if we combine power functions together, we get polynomials. Well, it's a negative power. That's the same as 3 times v to the negative 1. But you could also say it's a quotient or a rational function, either way. Okay, so what is happening? Discuss the behavior of this function around, okay, that's the key word, around the value x equals 2. So here's x is 2, right? If I go up here on my function, what does it look like my function is close to? It looks like it's close to 8, doesn't it? That looks like about 8. And so what I can do here is I can slide around. I think I can slide around. I should show it, huh? There we go. There we go. So look what's happening. I have here on the x-axis my x value, which right now is what? 1.4. And then this right here is my y value. That's what's coming out. And right now it's about what? 5.096? So as I get closer and closer to 2, closer and closer, right? What does it look like I'm getting closer to? 8, right? Now, when I was sliding this, you see how these jumps I had getting closer were pretty big? Like, look, I go 1.3. What's the next one? 1.4. Next one, 1.5, 1.6, 1.7. Right? I'm jumping by a tenth every time. Right? So you see this right here? I can change it to a slower jump. So now, when I jump, it's going to be 1.71, 72, 73. See how I'm going a lot slower to it? Now look at my y value, 7.4, 7.7, 7.9, 7. Right? Now I can go to 1/1000th. Now I'm, 1.991, 1.992, 1.993, and look at my y value, getting really, really close to what? 8. The limit is not asking you what is happening at 2. Okay? What you want to almost imagine is that we have, the best analogy I ever had of this is when we've looked at a function in the past, right, and we say, oh, plug in 2. All you did was go to 2, right, plug in a value, and you get that value, right? And so you basically said, cover up everything in the graph, who cares, and tell me what's happening at 2, right? The limit is backwards from that. The limit says, you don't get to look at 2. Hide that, okay? And look at what's happening right next to it. So the analogy that I was given was like a window. Here's a window. That's like the wood frame of the window. And you have like a shutter, and you open the shutter, and you can't see what's happening right down the middle. Okay, so there's my shutter. Can't really see what's happening in the middle because the wood's covering it. But what's happening on the outside is what you're looking at. Does that make any sense? Okay, so that's what's happening as I was coming in from the left, right? As I came in from the left, the closer I got to 2, the closer this got to 8. Now, will the same thing happen if I come in from the right? So now I'm going to pull in a point from the right side. Now, I'm pretty far away from 2 right now, aren't I? So let me get close. So right about here. And it went up. Now it's coming back down. Look at my x value. I'm going to take the other one out of there so it doesn't get in the way. So I'm close to 2, right? 2.3. Let me get even closer. 2.2, 2.1. That's close. What's my y value? 8.4. So as I get closer, it's getting closer to 8, right? But now it's a little bigger than 8. So when I came in from the left, it was a little smaller than 8, getting close to 8. Coming in from the right side, it's a little bigger than 8, but it's still getting close to 8, right? Getting closer and closer and closer. Oh, I went too far. There we go. Pretty damn close. So it would appear, right? The appearance is that if I come in from the left or from the right, it appears that the function is approaching what? 8. So at 2, the function's value is 8. Compare that to this. Now that's a piecewise function. What's happening at 2? At 2, what's the function's value? What's that? Well, it has to be at 2. Like if I tell you plug 2 in, everyone take 2, plug it into this function, what would you get? You'd get 8, right? Because I have a solid dot up here. But that's not calculus. That's college algebra. Now we want to close off the middle where you can't look at this anymore, and I want you to look at just the outsides as you come into it. So let me come in from the left first. So I'm going to approach here, moving 1/10 at a time. What does it look like it's approaching here? It looks like it's approaching 8, right? And I could go smaller steps, and I think you'd still be convinced that it's getting closer and closer to 8 as I come in from the left.